Good afternoon. Welcome to AP Statistics. My name is Mr. Royce. I'm going to be your AP Stats instructor for today. And if the camera is blocking your view, feel free to move to a different desk. And there is one homework assignment due tomorrow. However, even though it looks like the homework due tomorrow is quiz 9.1 front and back, it's actually front side only. So due tomorrow, front side only. So, in fact, let's talk through what's going on here on the front side. When you do the homework that's due on Tuesday, March 3rd, let's just read what this thing says. I appreciate that. It actually runs parallel to the pregnancy problem that we were doing at the end of class on Friday. So, as you look at the homework that's due tomorrow, problem 1 only of quiz 9.1, please also take out the pregnancy handout, or the handout that had the pregnancy problem. Let's compare the two. The problem says we want to determine the proportion. I'm going to start over. We want to determine the proportion of cars in the Wheaton Academy parking lot that are from a Japanese manufacturer, that is Toyota, Honda, Nissan, etc. In SRS, so for example, 40 cars from various lots around the school was taken, finding that 26 of the cars were Japanese manufacturers. So they're telling you right up front that we've got 26 out of 40. Now the question is, how do you symbolize 26 out of 40? Is that P hat, P sub 0, which is the hypothesized P value? Is it P value, or is it the capital P in an expression like probability that the observed P hat is less than 0.3, given that the true P hat, or the true proportion of P without the hat is 0.35. So of these 5, and there are 5 uses of the letter P, okay, so I'm hearing P hat, it's actually, that is correct. P hat is really a big deal in AP Stats. In fact, back when I taught at Stevenson High School, for the AP test, sometimes a class will get together, they'll make an AP t-shirt for like maybe APUSH or something, the students will design something and they'll gather funds. So one year for stats, you know what we did? We got a hat that had a P hat on it, nothing else, and so it's a P hat hat.
You only wore hats?
It was a P hat hat. So, although, yeah, I think it was only in the summer, because I guess you're not allowed to wear hats in school. But, so then, last period, I was telling the students, I thought, but we had it with Stevenson green with a yellow P hat. I thought, well, what if we ended up doing Wheaton Academy maroon with a white P hat, and then Lars Castle designed a P hat hat that I don't know if it's going to fly or whether it's got to be student initiated, student funded, the whole thing, but it might happen. You should ask Lars to see his design for the P hat hat. I mean, look at how powerful P hat is. In fact, in this study, we can find the mean of the sampling distribution of sample proportion, which is P, but we approximate it with P hat. And the standard deviation of the sampling distribution of sample proportions is the square root of PQ over N, but we can approximate that with the standard, not the standard deviation, but the standard error of P hat, which is square root of P hat. Q hat is 1 minus P hat over N. And then we end up building a confidence interval. Dan gets up, he stands at 26 over 40, he stands at P hat, and we add a margin of error, which is Z star, the standard errors in each direction. And recall, standard error, that's like a yardstick. It's like standard deviation. Standard deviation is a yardstick that measures deviations. It's like, how far should we deviate out from P hat to get Dan's left claw and Dan's right claw? Well, it's the critical Z, it's Z star standard errors. It's Z star yardsticks. So P hat is a big deal. Once you know P hat, you basically know how to build the P trap. So it's kind of a big deal. But in this problem, they're asking you to construct and interpret a 95% confidence interval. Look at how similar this construct and interpret. Look at how similar that problem is to the pregnancy problem, in which we're not saying pregnancy is a problem. It's a wonderful thing because we get married couples get pregnant, have children, it's like, wow, this is amazing. And then, so it's not really a problem, but if you can't conceive, that is a problem. And so then they go to this clinic, and we built a confidence interval, and in fact, right at the end of class, on Friday, we came up with 18.5% to 28.5%. And just want to finish connecting to what the homework is that's due tomorrow. So the homework due tomorrow, you can't just go to stat test A and get the answer. You have to write an essay. That's why there's so much space there for it. You have to write out a sentence for the randomization condition, which when satisfied justifies the independence assumption in the context of the Wheaton Academy parking lot. So you're gonna have to write a blue section to your essay. You're gonna have to write a green section, which has 10% condition, success, failure condition, not NP, but NP hat. You're gonna have to show all your work. You're gonna have to write a purple section on the essay for the homework that's due tomorrow. And then when you get to, so that's like all the model. It's like justifying use of this model. And then you're gonna have to show 5 lines of calculation, starting with P hat plus or minus the margin of error.
Whoa.
And you're gonna have to write out all 5 of these lines, but when you get down to this, after you write the first 4 lines, you're not gonna type in all this craziness into your calculator. Instead, you're gonna go to, let's sing it for the camera. We're gonna go to stat test A, which is called putting the A in AB 80 56 24 CD. Donate your card today. 82.
Oh, wow.
So you probably want to see that in slow motion. Probably want to see that in slow. How do they know in these musicals? How do they know when it's time to go in slow motion? It's like, I'll bet there's a cue, isn't there? Or do people just kind of feel it? It's like, oh, let's go slow.
Feel it in your bones, Mr. Rose.
Probably a mix of both.
Could be a mix of both. I wouldn't be surprised. It's like, wow, it's like they're doing the slow motion routine. So anyway, but notice it's not only calculate, but also interpret. So part A of the homework due tomorrow is to go all the way like through this. And then part B is to explain what that is. So you're gonna have to use the BOTS script in part A of the homework due tomorrow. And you're gonna have to use the IRS script in part B. By the way, you haven't even done this for the pregnancy problem. Would you please, now that you're like super good at this, because already those, before I started filming, we did an activity called quiz, 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 trade, quiz, 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 which means we got each quiz 3 times perfect, and then the other person got 3 times perfect. So yeah, that's what you missed if you weren't here. But go ahead and, since you're super good at this now, fill in parts B and C word for word. I'm gonna pause the camera while you do the work.
Really proud of Jack.
Jack said his answer was based on this sample, we are 90% confident that he said true, but I put in parentheses, because if you don't see sample proportion, it's implied that the true proportion of live births from women under the age of 40 who previously were unable to conceive is between 18.8% and 20.5%. So keep in mind, it's so easy to mess this up. It's so easy for you to go past tense and start talking about the sample. No, we're talking about all women who are struggling to conceive. Not just the people who are in the sample under the age of 40 who were previously conceived. Now, you could make this a little, so the context is also this clinic. So I guess that's the only coaching I would give for this is women under the age of 40 not past tense, but who come to this clinic. So that's present and future. Not who came, not past tense, who come to this clinic and were previously unable to conceive is between 18.8% and 28.5%. Now, can someone say out loud what it is you came up with for part C, explaining just in general what 90% confidence, actually in particular, in the context of this clinic, what does 90% confidence mean? Who'd like to give the IRS script a go? Take a volunteer. Camera. Okay, so what our volunteers came up with was, in repeated sampling, 90% of samples of size 207 will produce confidence intervals, so it's like we have 100 different confidence intervals, that capture, or you could say contain, or trap, the proportion of women under 40 who were previously unable to conceive who ended up coming to this, who not ended up, not past tense, who come to this clinic and have live births. So, I mean, that's a mouthful, but that's what it means. That's what 90% confidence means in this context. And right at the end of class, we're talking about, oh, by the way, suppose we are sus about their claim of 25%. We're like, wait, is this totally true? Because look, our p hat, if you take 49 over 207, it's only 23%. So you might be like, oh, false advertising, because our sample is only 23%. Well, it's irresponsible to report out a p hat without also reporting a margin of error. So 23%, it ends up being, if you take 28%, like 28.5 minus 23.6, it's about 5%. So it's really, it's 4.8%. So really, don't say it's 23%. Say we're 95% confident that the true proportion is 23% plus or minus 5% of women who benefit from this clinic. Now, so at the end of class, we said the answer was no. The answer was no. This is not enough evidence to refute the claim. If it had come out to something crazy, like if the confidence interval is 0.11, 0.13, which means p had to have been what, by the way? If the confidence interval had been 11% to 13%,
12.
then the confidence intervals, then the p hat was 12%. The margin of error is 1%. So another way to say 0.11, 0.13 is 12% plus or minus 1%. Okay? Hopefully that's connecting in. If both clause are beneath the key value, which in this case is 25%, in an election the key value is 50%, here it is 25%, then we could say we have enough evidence to refute the claim. But both both clause were not beneath 25%, so we say there's not enough evidence. Now, notice that on the homework due tomorrow, you have to write this whole essay, get down to this for part A, then you can see that part B corresponds to part C here. Any questions as to what's going on with the homework due tomorrow? Side one only, it's worth 6 points. Sometimes, occasionally I get students who, like, they forget to do the homework, so they do the homework really quick in the first 5 minutes of class. Keep in mind that if you're doing homework during class, first of all, it's not permitted, but if you sneak that, anyway, I'm not, any eye contact I'm making during the speech is incidental. I'm not publicly confronting anyone. I'm just saying that in general, you get a point off if you're doing homework during class, so it's the highest you can get is 5 out of 6 and says 6 out of 6. So just, so last call for questions on the homework.
So is this not, the answer is not gonna be online though?
The answers will not be online.
Okay, so this is okay.
So this is, but you do have a similar problem in your notes.
Yeah, no, I know, because usually we do practice quizzes.
This is a homework assignment.
Oh.
This is a homework assignment,
Okay.
and it's due tomorrow. So yeah, I'm glad you asked.
My bad, yeah.
No, it's not your bad. I mean, it's just I'm glad you asked.
You're good, Dan.
So,
You're good.
and we were talking about statistics in the news. There are some things coming up with coronavirus and other things having to do with living together before getting married. There have been some fascinating studies done. So check those on the AP Stats topic. It's a new one called Statistics in the News. And the thing with coronavirus is that they're taking samples basically of coronaviruses and finding out how much, on average, how long do they live. Suppose I had the coronavirus. I mean, I have no reason to believe that I do, but suppose I did, and we're touching this. Suppose I were touching this $300 stylus, and then I had someone else how long on average does the coronavirus live on a plastic surface? Well, I think they're on brass and stainless steel, I think they're saying 2 hours on average, but it's there's a true mean. There's a true mean mu. And so statisticians are out there today trying to build a mu trap for the 95% confidence interval for the amount of minutes that the coronavirus is alive on steel and brass surfaces. It's different averages for cardboard and other things, but so read Statistics in the News. It's online if you want to take a look at what the recent studies are on. I'm sorry?
Do you know the average that coronavirus survives on paper?
I don't.
Dan touched my practice.
So just,
I don't have the coronavirus.
and yeah, there's no reason to believe that anyone here has a coronavirus. Well, let's continue on with our lesson. So go ahead and turn the page and join me on problem 28. So we're continuing with this lesson, number 28,
Another pregnancy.
pregnancy 2. And
It's the second part.
so, pregnancy number 2. And here we have the San Diego Reproductive Clinic. It's the same one, but they're a little bit embarrassed about their margin of error. It's like there's a really big margin of error. I mean, can you imagine how embarrassing it would be to say, well, I think the proportion of people who are going to vote for Bernie Sanders is 40% plus or minus 40%. It's like, oh, come on. It's like you're not really saying anything. But if you said 40% plus or minus 1%, you must have done a lot of research. You must have had a big sample size. So notice what's involved in sample size calculations. We have already been doing some sample size calculations in this course. Like, for example, we asked you, what's the minimum sample size required so that we can satisfy both the success and failure conditions? And you remember you did like NP has to equal 10 and NQ has to equal 10, and whichever was bigger of those two, that's when you kept, remember doing that? That was a sample size calculation. Here's another sample size calculation. What if we wanted to cut the margin of error in half? What would we have to do to the sample size? I mean, currently the sample size is 207. If you want to cut a margin of error in half, look at what happens algebraically. Margin of error gets multiplied by 1/2. To be fair, you have to multiply the other side by 1/2. But if you're going to bring a 2 that's outside parentheses, inside parentheses, what's going to be, or inside the square root? What number inside the square root? Yeah, it's got to be a 4 in there. So it's going to be z star, and something strange is happening there. That's okay. I'm just going to go like this. So z star times the square root of p hat q hat over 4n, which means you've got to use, if you want to cut your margin of error in half, which is impressive, that will increase your reputation as a researcher if you can have a smaller margin of error. You've got to have 4 times as many people. You've got to have 828 patients. And we have concerns about that because a sample that large may be more than 10% of the population, of more than 10% of the population of women struggling to conceive. I mean, how many women really are there struggling to conceive? We've got to have a sample of size 828. Are there really 8,280 in the greater Los Angeles area? Well, there might be, but that's a concern, is that that sample may be a violation of the 10% condition. Now, let's take a look at the graduation problem, unless you have any questions on how we came up with the number 4. Okay, 28. It's believed that as many as 25% of adults over 15 never graduated from high school. Now, we wish to see if this percentage is the same among the 25 to 30 group. So how many must we survey? Another sample size calculation question. Sometimes for students who skip this lesson, they get driven nuts, if you will, when they're asked to calculate the sample size, because you got to be able to do a lot of things here mathematically. But look, we want our sample size to be 6%. So when you see this, you're responsible for knowing, oh, they're giving us the margin of error at 90% confidence. They're giving us what's called the confidence level. Confidence level is 90%. Okay. So what should the sample size be? Start out with knowing that the margin of error is z star squared p hat q hat over n. So they give us a margin of error is 6%, 0.06. Does anyone recall, how do you calculate the critical z value, z star, for 90%? Inverse normal of what number? 0.95. By the way, that comes out to 1.645. I've got it memorized, but if you don't believe me, you could type in inverse normal of 0.95, we'll have it. Now,
Yeah, it's 90 here.
for what to put in for p hat can really flummox some students. That means to deeply frustrate them. I'm flummoxed because look, we're trying to find p hat. We haven't collected the data yet. And so this can be a real brick wall for a lot of people. Well, there's 2 ways out. One is that since we're still in the survey design stage, we're just trying to figure out how many people should be in the survey. We don't know what p hat is. So you can either say it's probably pretty close to what it is for the older people. So you can use 0.25, 0.75 over n. Now, understand that what if you're doing this study for the first time? What if no one's ever answered this question for any age group? Then what would you use for p hat? Well, the most conservative answer is 0.5. is 0.5. Because if you, think about it, what does conservative mean? It's like, we're gonna find out that this stays in the numerator. So the maximum value, and this is nice to know but not need to know, but for those of you who maybe remember taking a pre-calculus class, we're essentially trying to find the maximum value of p times 1 minus p as a function. It's like, suppose our function is x times 1 minus x. That is a parabola with x-intercepts at 0 and at 1, and it opens down, and the maximum value of this occurs at the average of the x at 0.5. So it turns out that the worst case scenario, if you don't know what to put in for p hat, and sometimes they don't give you a previous study that you could use as a reference point, then put in 0.5. You should never be saying, there's not enough information in this problem, Mr. Royce, because I don't know what to put in for p hat. Just put in 0.5. But here we do have a reference point, so we'll do that. So, friends, the algebra here is not that complicated. We're gonna have to square both sides. So this is gonna end up being 1.645 squared times 0.25 times 0.75, and then we're gonna have to multiply by n and divide by 0.06 squared. So, would you please type this into your calculator? Oh my goodness, please don't type in like square roots. No, just get it to here so you don't have to type any square roots into your calculator. Please now, take out your calculator, type it in, and see what n should be. I'm gonna pause the camera while you do your type. And we're back.
We're back. How are you
Friends,
doing today, Mr. Royce?
Round it up, you get 141 people. Any questions on this one? Number 29. Okay, let's keep going. Now, I think the next one is done for you, but look, the only difference, if you're gonna change, and what if you want a margin of error of only 4%? Replace margin of error with 0.04, comes out to be 318. Oh, by the way, in red, the more cautious approach is to let both p hat and 1 minus p hat, okay, basically 0.50 on both. If you did the more conservative approach, this sample size is a lot bigger. The one for you to practice is on the next page. So turn the page, do part C on your own, on the top of page 4. So people have been doing their calculations.
And I got 2 Yahtzees as well, Mr. Royce.
And with 3% and you round up, it does come out to 564 people. By the way, the more cautious approach would be 752 if we didn't have the 25% to go off. Do you have any questions on this concept? The concept of how to calculate sample sizes. So, yeah, there's a little bit of math in there, some algebra. And then, finally, alternatively, yeah, this alternative stuff is nice to know but not need to know. Okay, graduation again. As in exercise 29, we hope to estimate the percentage of adults. Now this time we're going 95% with a 2% margin of error, so watch out. There's 2 things you have to watch out for. What should my margin of error be, and what should Z star be? And notice, you can probably remember the inverse normal of 0.975 gives you 1.96. And again, it just changes the numbers a little bit. Comes out to huge sample size. Oh my goodness, we want to be more confident and a margin of error of only 2%. This is an enormous sample. Some might even characterize it as ginormous. No. And then the conservative one would be even bigger. So, any questions on this lesson?
No.
Now, let's, and we have some time. I'm going to pause while I hand out the next lesson. Look at the next. This is period 6.
I was so uncomfortable.
And here we're looking at hypothesis testing and proportions, and we're going to be talking about the null hypothesis for the first time, where we actually have to write it out. This first, we've talked about the null hypothesis, H sub 0, and the alternate hypothesis quite a bit, but now we're actually going to have to write them out. And imagine that we've been hearing since we were kids. Suppose you grew up on a planet where most parents would teach their kids, oh, by the way, watch out for dogs because 25% of people get bitten. 25% of dogs bite people. And you want to test that hypothesis. So the null hypothesis would be the proportion of dogs bite people is p equals 0.25, and the alternate hypothesis could be either greater than, less than, or does not equal. But suppose you're the sort of person who's suspicious. And then you're like, what's going on here? Because, I know when I was running cross country, when I was in high school, my senior year, I got bit by a dog. I was out running, and I thought,
do you have rabies?
I was Well, they checked, they took me to the hospital but first what they do is they check to see if there's any record of the dog having rabies, so that they don't have to give me rabies treatments, because you can't really check someone for rabies right after they get bit by dogs. What happened was, this is up in Waukesha, Wisconsin, I turned the corner and this dog was in a fenced-in yard, and somehow the dog came out through the gate, and I thought it would be a good idea, I was wrong, but I thought it would be a good idea to like run really fast. I mean, that's who I am, I'm a runner. And then the dog's claws just kind of like, its jaws locked into my calf
Oh.
muscle, and it's like,
Oh,
so
is it
I,
like
it
a
was,
bear trap?
please, this is my story. So then, I was really upset, I went home and told my parents, my dad was
Were you
upset, how could
bleeding?
this happen? There's probably some blood, and then, but it wasn't like spurting, but it was, they took me to the hospital, and then the police went and they got that dog. Now, my friends who saw me get in the police car, I went to the hospital in the police car, and my friends were like, whoa, what's going on over there at the Roy's residence? And then I just got bit by a dog. So then the next time I got bit by a dog, I thought, I'm gonna take a different strategy. I'm gonna stand and yell at the dog, and that didn't work either. But I mean, it's
So this has
actually
happened
better.
to you twice?
So then, the only time, and there have been times when it worked, because I'm a runner, I'm out running, and then dogs sometimes chase me. So then what I learned to do, the thing that's been most effective, is that I just stand there, just kind of relax, and like, I don't say anything, I don't run, I just really calm. And then usually the dog will just bark a little bit. And then, so that's been a much more successful approach. Now, but I'm the sort of person who thinks, you know what, I'll bet it's really more than 25% of dogs that bite people. So what we're gonna learn how to do is do hypotheses model mechanics conclusion, but hypotheses will be on the upbeat. There'll be 1, 2, 3. Hypotheses model mechanics conclusion. 1, 2, 3. Hypotheses model mechanics conclusion. So we'll see you tomorrow. Have a good night.